So with this equation right here, we're trying to solve for A, and we're trying to make these two ratios equal each other. And there's a couple ways you can look at this, and I might show you, I'll show you both ways. Now, the way that I looked at this initially is I obviously want these to be equivalent. So if the top two, if the numerators are already equivalent to each other, then to make the ratios equivalent, I just need to make sure that the bottom two are equivalent. And at that point, I can just set up an equation that says a times the square root of 7 equals 7. And for some of you, you don't really need to do the full math because maybe you already have a pretty good understanding of square roots and how that works. But if you need to, you can divide by square root of 7. And that means you have to do the same to both sides. One thing we learned this year is how to rationalize the denominator. So I'm going to do 7 divided by square root of 7. Now to rationalize, I need to multiply by square root of 7 over square root of 7. And when I multiply across, I'm going to get 7 square root of 7 in the top, in the numerator. Square root of 7 times square root of 7 is actually just 7. All right, and you can go through 2 steps to find that out, but that's essentially what's going to happen here. And then those two cancel out, you're left with just square root of 7. So that's how you can find what A equals. So maybe that's how you thought through it. Another thing you can do with this is you can see that this is a proportion. So if that's a proportion, why not do cross products? And that can be done. So if I do 7 times 3 square root of 7, and then I can get A square root of 7 times 3 square root of 7. All right, so the left side is a little more straightforward because I'm just going to multiply my two number terms together. Essentially what I'm doing on the left is 7 times 3 times square root of 7. And essentially what I'm doing on the right is A times square root of 7 times 3 times square root of 7. So there's no particular order that these have to be in. So anyways, if I multiply on the left, the 7 times 3 gives me 21 times square root of 7. That's all well and good. On the right side, square root of 7 times square root of 7 gives me 7. So 7 times 3 is 21. Essentially, this all comes down to 21 times A. You might take 2 or 3 steps to get that, but you can get to that right there. If I divide both sides by 21, then I get A equals the square root of 7. So it doesn't matter which approach you take, you will be able to find the correct answer if you're doing the math correctly. We have one last unit we're going to do. It's going to obviously be a smaller unit. And really this unit is stuff that you should have learned at the end of last year in algebra that for whatever reason, most of you didn't learn. Actually, not for whatever reason. The most likely reason is whenever we went to remote learning, a lot of people just didn't keep up with what they're supposed to learn. And that's not, I'm not saying that as a criticism, I'm saying that just as a reality. So we're going to be doing some stuff that you should have been learning last year. We're not going to go as in depth as you would have in an Algebra 1 class, but we are going to learn one of the most important skills that you needed to have learned last year. I think when the schools shut down, you were right at the beginning of learning the stuff, so it might look familiar when we get to it. Maybe for some of you, it doesn't look familiar at all. So what we're going to do is we're going to start off today with multiplying binomials. And that's a very mathy way of saying we're just going to take an expression that looks like this, 3n plus 2, and multiply it by another one that has the same sort of setup. This is n plus 3. Notice there's a variable plus a number, a variable plus a number. And all of them have the same appearance to them, okay? Just with different numbers that we're multiplying. The good thing about these types of problems is that this is just using distributive property. And maybe before, well, let me solve this first one, and then I'm going to explain what we're going to be doing, which is a little bit different. So it's good to start here because we're going to see what happens if I multiply these together. So when I'm talking about doing the distributive property, I'm really taking that first number, that first term, and I'm going to multiply it by everything in the other parentheses. Now, when we multiply variables together, so this first one that I'm doing, 3n times n, is the same as 3 times n, which is the same as 3 times n squared. So that's how we get 3n squared. I just want to remind you how your exponents work. All right, so if I'm doing 3n times n, I'm going to get 3n squared. when I do 3n times 3, just the numbers multiply together, and then that n is still being multiplied by, but that's just going to hang out at the end. So it's going to be 3 times 3 is 9, positive 9 times n. All right, so I've multiplied everything with my first term. If you're the kind of person who likes to keep track of your progress, you can kind of be like, okay, I've done that one. So now I'm going to do 2 times both of these terms. 2 times n is just going to be 2n. 2 times 3 is 6. There are going to be problems you can see where there's negatives. There are going to be times whenever we have negatives that we have to consider. All right, and that will turn our products negative. We're going to see that with another example. But let's go ahead and finish this one out. We do have like terms. We have like terms anytime like this. There's a 9n, there's a 2n. So I can just combine those together to get a final answer of 3n squared plus 11n plus 6. Notice these two got combined, but there's no other n squared term and there's no other number term. So these just kind of stay how they were before. All right, so that's multiplying binomials. What we're going to be doing is we're going to be factoring quadratics. And a quadratic is this kind of equation. Technically, a quadratic is any equation that has your variable raised to the second power at the highest degree. So basically, this one has n raised to the second power. And the standard form of a quadratic looks like this: ax squared plus bx plus c. And this x is technically x to the 0 power, and that's x to the first power. So you can see what's happening. It's going to the second power, then to the first power, then to the 0 power. But let me erase this because we don't typically show that. So a quadratic, the highest, we call this the degree of the polynomial. I'm throwing out some terms right here that aren't really going to be essential, but maybe it's something that you'll remember later when you get to Algebra 2. So the degree right here is a quadratic has a degree of 2. All right, now I'll just stop there because we don't need to get any more in depth with that idea. What we're going to be doing is I'm going to be giving you a quadratic. Maybe I give you this one: x squared minus 2x plus, well, let me do it this way, plus 2. No, that doesn't work. Plus 1. Okay. So in this case, if I give you this, I say, what are the two binomials that I started with? You know, something plus something or something minus something. So basically, I'm going to say, here's this. What does it look like if you unmultiply it, if you factor it? So some of you might remember having done stuff like this before spring break last year, but that's what we're going to be doing. This is going to be super important when you move into Algebra 2. So let me go ahead and clear this because this particular problem doesn't relate. I just made that one up. All right, so now let's kind of go through another example. I'm going to take 2x and I'm going to multiply this by everything on the right side. So 2x times 2x, the 2 times 2 becomes 4. The x times x becomes x squared. You're always going to have a square term. 2x times negative 3, I'm multiplying by negative 3. That's how I can think of it. So 2 times negative 3 is negative 6, and then x is still there. Now I can multiply 3 times 2x to give me positive 6x, because there's no negatives there. And then 3 times negative 3 gives me negative 9. Now notice what happens. This one's a little bit weird. When I multiply this, when I combine these like terms in the middle, so I still have the 4x squared, and I still have the minus 9. But when I combine negative 6x plus positive 6x, it cancels out. So really, I just have 4x squared minus 9. That could be my answer. But what's kind of hidden in there, this does still match this format. But what I've technically got is a plus 0x that I don't need to show. All right, is this making sense so far? Any questions? All right, let me just do one more example. You might or might not need to see it, but you're going to do every even problem. So I'm going to show you a few of the odd ones, and I'm just going to jump down to, I did 17 in first hour. Let's do 15. Yeah, that'll be fun. All right, so let's see what we've got here. I've got 5v times 3v. So hopefully we can already see what to do here. 5 times 3 is 15. V times v is v squared. 5v times negative 6. So it's going to be negative 30 when I multiply the numbers together, and then that v is still being multiplied. So now let me multiply 4 times 3v. 4 times 3 is 12, positive 12, and then times v. And then 4 times negative 6 is negative 24. When I combine my like terms, the last thing you'll need to do is combine your like terms. So these two get added together. Negative 30 plus 12. You can do that on the calculator if you want to. You can reason through it in your head, but negative 30 plus 12 is that's essentially the same as 12 minus 30. And that's going to give us negative 18. So I'm going to get 15 v squared minus 18v minus 24. And that's our final answer. So like I've been doing on a lot of these worksheets, I have the answer key down at the bottom. I'm going to show you real quick that you can double check all your work right here. We can make sure we did this right. Look at that, 15v squared minus 18v minus 24. So we're good to go. You can check your work, but like, the purpose of having the answer key is so that you can do all the work and double check to make sure you're doing it right, not so you can just copy the answers down. So I want you guys to work on this today. You have plenty of time. If you have questions on it, certainly let me know. Remember, once you know how to multiply it going forward, we're going to learn the reverse process starting next Monday. Tomorrow is your benchmark test. So with that, I've said everything I need to. If you have any questions, stick around. Otherwise, you can have a wonderful day, and I will see you tomorrow.